architectural and logical data model
Okay.
conformed storage table types today.
Okay.
Yeah. So let's go to the architecture first. So Data Hub is basically an operational data store that consolidates, transforms, and conforms historical data across the enterprise. So this diagram elaborates that we can have data from any of the systems. So it could be their legacy core systems, their insurance suites or Guidewire or any other enterprise system. So we can have data from uh, any of them into Data Hub, right?
Okay.
So,
So this is like any other data warehouse, right? I mean,
yeah,
when we talk about the data hub, right? It's just a data
right,
warehouse that is available that can pull the data. Okay.
right. It is basically a warehouse, and it's a fancy name we have given the Data Hub. That's all.
Got it.
Architectures. So from Guidewire perspective, we have our sources as Guidewire Policy Center. We have Guidewire Claim Centers. We refer them as GWPC and GWCC. So these could be your sources, and from these sources, using the ETL tool SAP boards,
Mm.
we uh, creates jobs, workflows, and in those workflows, uh, we have our data flows. In those data flows, we have some query transformations. So, and we have a data store as well, in which our list of tables we have over there,
Mm.
source as well as the ODS, and we can drag the tables into the SAP boards query editor, and we can make a flow, we can make a pipeline, and in the query transformation we can join those tables and put a where clause. I'll just just a second, I'll show you
Bot
with
spot,
this.
what you're talking, I know, I understand.
Okay, fine,
I'm aware about it. Yeah.
fine. So we get the data from there using the I mean
Course.
SAP bots, and we define our file structure in the extract part of that. We first we have the extract part in which we pull the data, and we define the file type as well over there.
Mm.
So from source, we are getting the data into SAP job server. We have a file location,
Mm.
extract file location, extract
Mm.
folder, in
Okay.
which we have our files. So in the extract, we generate two extract files. One is the uh, extract file, and other is the control file.
Mm.
Control file holds the metadata actually.
Mm.
We'll see them in next slides.
Sure.
So let's just overall discuss how things go. So for policy center and claim center, it comes this way, and so it was actually the hand coded, the previous one, the previously it was hand coded, but now it's I have kept this slide just to know, to give you a context about what Guidewire had and now what it has. So previously it was hand coded, and but now the dial has come, that is data integration and automation layer. We do not need to hand code post getting the data, so it automatically pushes the data from the transformation tables to the uh, main tables, that are the conformed storage tables, CS tables.
When you say
Same
that
here
the
for,
when you say that the hand coded extract, right? What does it means? The term?
it means so first we have to create the data flows and workflows to extract the data
Yes.
into extract jobs.
Uh-huh.
We got the data into text files, then we have another job which runs post extract, which is transformation job,
Mm.
and in that transformation we we do our validation. We put our validation rules. We
Mm,
put our cleansing rules, the
mm,
transformation rules,
yeah.
and push the data into one TRF table, or we can say the staging table.
Mm,
And then from that staging table, the data is that staging table lies into Data Hub only.
okay.
Yeah. So in the same database, and from that staging table, which actually doesn't have any primary key or foreign key, any references. It's
Okay.
just a table to hold the data. uh, After cleansing or massaging the data, we hold the data into that staging table, and post that basis uh, the data or entity we push the data into their main tables, which are conformed storage tables. Either it is transaction table or it is base delta tables. So
But that's also
transaction
in the data
tables,
hub, right?
yeah, they are all in Data Hub. They are all
Okay.
in Data Hub.
Okay.
So previously, from transformation tables, staging tables to main tables, the data
Mm.
was, hand codedly pushed, but now it's a dial data integration and automation layer which push the data into uh, main
The
tables,
target table.
confirmed storage. We just have to pass their transformation table name and their confirmed storage table names. That's it.
So,
It's a fancy name. Dial is a fancy name. It's just
okay.
the JavaScripts which does all these things.
So it's basically that schedule and loading of the data, right?
Yeah, yeah.
Okay. And this hand coded refers to basically the query transformation and the other things that we are doing it in between the source
Right,
and then the
right,
target.
right.
And also one other question here. So in the
Mhm.
screen, you have mentioned two outputs, right? One is the file that is getting created. So
Mhm.
from the data service, so from the source, when the data is created, it always creates a two separate files, one for the actual data file and one for the control file. Then
Yeah,
it actually uses the query transformation to load the data into the stage and eventually into the main table. Is that
right.
the architecture?
Exactly,
Okay. Okay.
exactly, exactly. So this is the next part of the file system.
One more
We
question over
have,
there. One more
yeah,
question over
yeah.
there. You did mention that there is no primary key there, right? In the stage.
Staging tables, right?
So when
The
the data is
TRF
getting
tables.
loaded from the source into the target, right? How is the delta managed without a key?
So staging table is always truncated. It's a truncate and load.
So we are bringing all the data from the source into the target every single time.
No, if it's an initial load,
Uh-huh.
then yes, all data. But
Uh-huh.
if it's delta load, then there is a table for ETL table that
Uh,
helps track the data. The incremental data. ETL table, which holds the data. The previously, suppose I got the data till 1st of April
Uh-huh.
in my previous load. Now I have to load the data from 1st April to 25th April. That ETL table for each entity, which has entry for each entity, will hold the date, and from from whenever the delta load runs, it pulls the date from there, from date, and get the data from source and push it to the data.
So that's sort of a control table that is maintained within the data hub
Right,
itself.
right, right, right.
So it's not
That's
utilizing the data. I mean, it's not utilizing the bot's delta functionality. It's primarily relying on the control table to determine which data that need to be brought in from the source into the stage.
right, right. That's ETL table to, hold. That helps to track. Uh, I mean, these delta changes.
Okay.
Also, yeah, I'll show you the table as well.
Sure, sure, sure.
ETL user extract entity. That table name is ETL extract user entity.
TL extract.
Okay,
Hmm.
it's ETL underscore user underscore extract entity. I'll show you.
Okay, no problem.
Okay, so in the files we have two types of files that we discussed, right? So these are those two types of files: source, extract, control files, and then those files are then consumed and pushed to Data Hub.
Okay.
So, yeah. So delimited files with pipe and tilt and pipe signs. So this is the example of extract file
Okay.
where we have our data and the columns which we pulled from sources, and the control file holds the metadata, which is the source system entity, file name, from date and to date, from which date to which date the data is coming. If we have any amount column, we have sum of that
Value.
column, and in later stage we compare what we pulled and what we got into data hub. Did that amount column
Right.
matches?
Okay.
Yeah, yeah.
But
All this.
when we load the data that is loaded into the data hub, right? That
Mhm.
is from the text file or that is coming directly from the source file itself?
So we have one combined job for. So initially, if I talk about the initial load,
Uh-huh.
so uh, I mean it's a full load, right?
Correct.
So it's a truncated load. So what happens? We extract the data from sources
Correct.
and put it into the text files
Mm-hmm.
into data hub, job server on one file path.
Okay.
We do not need, so I mean source system. Now we got the data into text files. Now we do not need source systems. What we
Okay.
will do now is we have the data in our text files on job server. Now we'll pull those files and do the cleansings and validations and put it into the transformation tables, which are the staging tables.
And this is something the Guidewire itself is providing this process in the sense like, let's say that
Yes,
there is
yes.
going to be a policy center table. If I
Mhm.
wanted to get that data loaded into the data hub, the process that they
Mhm.
have defined is they will have the program to load the data into a text file. Then the data
Yes,
is loaded from the text file into the data hub stage. And then there is transformation from there and then it will load it to the main table.
yes.
But then the other picture, right? The one with the slide that you had earlier, if you can just go back one slide before, right?
Mhm. This is
So here, why is it actually showing it as the text file going it as a onto the bottom? And then what is that, hand coded connection that is going from the source
So it
directly
is
into the
it
tab?
is only the extract part. It is only the extract part. This is not. So we will see in next
Okay,
slides. Yeah.
okay,
It is only the extract part.
okay.
Yeah. So this is so this is basically to decouple the integration from the source system. That's why
Hmm,
it is done in text files.
got it. Okay.
So for claims and policies, data is extracted from the source, 2 files per extract. Data
Hmm.
file, which I mean delimited flat text files we discussed, and control file, metadata containing counts and totals, yeah, for audit purpose. And next is data is extracted to meet the specifications of predefined extract structure. Multiple tables may be joined together. Sometimes temporary tables can be used there, right? Before writing the files into the landing zone, which is our data hub, the extract files are archived in case of the delta loads and deleted and recreated in case of the initial loads.
Okay. And this joining and all those things is only when the data is loaded into the stage, right? When the
Right,
file is
right.
actually created, it's a flat one-on-one table to table.
Yes,
Okay.
yes. Then then we work on that file data only. We do
Okay.
not join anything.
Okay.
I can take a snippet of one of my existing project and I can show you what
Okay.
is actually it is getting. For billing center, it is direct. So we do not generally join for billing center. It's the entire table we pull. Only joins required is for the exceptions of the type list. So we have some codified values, and
Hmm.
we have to get the values from the type list tables. Then only we joins. Otherwise, it's
What does
fine.
type list means?
Type list is, suppose you have a currency code one,
Uh-huh.
and in your main table, in your billing table, and there is a different table which will hold the value, the name of that currency code, which is
Okay.
USD or rupee or any other.
Okay.
So in that case only, that
So
type
we'll
list. These are the type lists.
so it's sort of a lookup information, right?
Lookup. Yeah, we do a lookup.
Got it. And this is done when the data is loaded from the file into the stage.
Yes, yes.
Okay, got it. And you said that, when we load the data from the billing center, we don't have this issue. It's going to be always a one-on-one table to the target.
Yeah, yeah, it's one.
And that there also, when we are going to do it for the billing center also, we will
Mhm.
have the file in between.
No, it's direct load into the table.
Oh, so it's only for the policy center and the claim center we have the files. Billing center have no
Yes,
file.
no files.
Got it. Any reason why it is done like that, or is billing center came late into the game?
Uh, no, no idea. But since starting, they are using it, and truly speaking, we do not get much development work for billing center as well. So it
Oh,
was
it's
one
in.
or two entities. Yeah. So majorly it is policy center or claim center. Claim center is also less, but policy center is a huge
Major, right?
development work. Yeah, yeah, it's major.
Okay.
So ETL transformation views, these are the views. A TRF view transformation combines entity-related staging tables into a single view. So we have a few tables for one entity in billing, then we join it and create a view. That's it.
And this is done in the data hub.
Yeah, it's done in Data Hub, and this is just to uh, just for the name and nomenclature. The views, all the views should start from v underscore trf underscore, and then the entity name, whatever entity is. So if you could see in this screen, we have vtrf bill, charge com, then we have charge pattern, bill account. So,
Okay.
so this is the nomenclature is very important, very important.
And these views are actually provided by the Guidewire itself. I mean, it's like a
Guidewire
standard
itself.
views. Okay.
Yeah,
And the
next.
interface that you're showing, this is the data hub interface, right? The screenshot.
Yes, yes, yes.
Okay.
It's into the SAP boards.
Oh, this is. But SAP bots has a slightly different. Okay. Yeah, you
This
have
is
the
this
repository,
is
right? Yeah, yeah.
yeah. The staging area. This is for ETL transformation for the policy and claim. The staging area is made up of singular transformation tables that have no primary keys and relationship to one another. That we discussed previously in the slides. So staging tables do not have any primary keys or any relationship with anyone. There is a corresponding TRF table for each entity. So every entity will have one TRF table, transformation table.
Every entity will have one transformation table. What does it mean? I didn't understand.
Okay, entity refers to the if it is policy
Uh-huh.
or if it is policy line, if it is premium transaction. These are the entities. So we will have, suppose if it's premium transaction for commercial auto.
Okay.
Commercial auto is a I mean line of business, LOB.
Mm-hmm.
So we will have a TRF table for that, which is like TRF underscore CA
Mm-hmm.
underscore uh, uh, prem PREM underscore TRN. So the name is, very particular.
Okay.
So TRF underscore CA underscore prem underscore tran, TRF prem tran. We
When you
say
say that, this is the entity, this is the actual table itself which holds the data.
yes, yes. That's the staging table or
Got it.
TRF table.
Okay.
So
Okay. So
one
you're referring to
entity.
TRF as
So,
the staging tables, which is a one-on-one coming directly from the
right,
source.
right.
Okay.
After messaging all the data is pushed to the TRF. You could see over here. TRF, PA driver, personal
Uh,
auto, line coverage term. These are all the entities, and every entity will have their own TRF table. So first, the data is extracted into the
uh,
file, and then the extract part is over. Now we have the file on our server. We read the file, we do the validations on the data. If we have to remove the null records, so we'll put that in error that
Mm,
these records have null, these are null records, and these records have to be considered into exception.
mm,
So all these validation are done into the next job, which is our TRF, job ETL TRF, job
mm.
ETL TRF, which is to transform the data and push it to the staging table.
Okay.
Right. I'll,
And
I'll,
the one
I'll
which we are talking about, this the one which you are actually showing here, is the actual table, actual stage table, right? After the
yes, these are
transformations.
these are all actual stage tables.
Understood. Okay. Which is loaded from the file.
Yeah, which is loaded
And
from the file. Post loading from the file to the TRF tables,
ah,
we have the third part, which is to load the data from the staging tables to the main tables, which are our confirmed storage tables, which is done by dial. Dial is just a JavaScript which pulls the data from there and push.
it into this one. But behind the scene, that is also data services, right? Which is loading from the
Yeah,
stage.
yeah, yeah.
Okay.
These are all, yeah. I mean JavaScript, that is.
Okay.
Right, and this is for billing center sources to staging tables. Then dial pulls it and push it to the main tables.
The sources directly into the staging table. And
Yeah.
then, so when we are doing that, right, if you can just go
Mhm.
back. So in case of the billing sender, when the data is loaded from the source into the stage, there is no transformation involved, or we do the transformation in that time itself.
We do the transformation there if
Okay.
required.
Okay. The difference is
Staging
that we are
table,
not creating a file in between and loading it from there.
any data which comes to the staging table or the transformation table is
Hmm.
already transformed.
Okay. And from the stage into the main table also there is transformation happening via the
No,
dial.
no,
No.
no, no.
Okay.
It just takes the data from the staging table, because staging table has all the columns. Now,
Okay.
dial has to decide from which, which columns to be put into which tables, and we
Okay.
define the table structure before that.
So which means that from one stage you can load it into multiple main tables.
Yes, we can. There
Okay.
are few,
Okay. Got it.
but the column name should be same.
Yes.
Yes. So that was for billing center, and this is for policy and claim
Policy
data.
and claims.
So sources to extract files, files to TRF. We do all the transformations, and then we just sit back and relax. We just
Mm.
pass the parameters to the predefined data flows, uh, the TRF table name and the confirmed storage table name. Rest the dial does to push the data. If it's base delta, then it push the data to the base table or delta table. And if it is transaction data, then it push the data to the transaction table.
What would be the difference between those two if you can explain that? Base, delta,
Yes.
trans, LADNT?
Yes, we have those in next slides.
Okay.
Then, so we are done with the transformations. Now
Hmm.
we have our dial, which is data integration and automation layer. It's a Java-based code generator, and so it refers metadata which is stored in our metadata foreign key reference table. We have MDFK ref table. Whenever we create a DDL script for creating tables, we have to ensure that whatever constraints we create on the base table or delta table or the transaction tables, the we should create an entry into MDFK ref from which the dial picks the references, and it drops the constraints from all the tables before loading the data. After the data is loaded into the tables, it recreates those constraints on those tables.
Could you repeat that? I wasn't very clear about that part. Could you repeat that MD?
Yes, MDFK ref. This is
Okay.
this is actually a table
Okay. Is it
which
one table
holds.
or is it one table per entity?
No, no, this is one table for all, for all
Okay.
all the tables into data hub. So it will hold the table name, TRF table name. It will hold the foreign key table name, foreign key column name, primary key table name, primary key column name, and the constraint name.
Okay.
So now the dial knows from this table that these table uh, has the foreign key and primary key relation. Now it drops the constraints from the main tables
Mm.
and loads the data into the data hub and recreates the data using this table. uh, I mean the data available in this table
And why we are doing it? Is it to
for the performance.
data load performance, right?
Yeah.
Okay. So when we do
Okay.
this, right? What
Mhm.
so and then once the data that is sitting in the data hub is not consumed directly by the reporting, right? Then it goes to the info center only. Then
No,
only
no,
it will consume. Oh, it
no,
is
no. Info
consumed.
center is for different purpose. If so, I have worked on outbound reports.
Hmm.
The reports are basically generated from data hub.
From the day. So when you drop this, I'm just trying to understand this, right? So let's say that
Mhm.
you have a main table that you're actually
Mhm.
loading it from the staging. So prior to that, you will look at the metadata table, MD, FK, ref table, drop all
Mhm.
those references from the main table, load the
Mhm.
data, and then recreate the reference, right? So while this reference is dropped, right, and while the reference is dropped, when the
Mhm.
user is going to access the data, would that not cause a performance issue?
No, see what happens is so we define all the references into this table.
Hmm,
We do not drop and create.
hmm.
It's the dial or it's the Java code which does all these things. So they generate the script to drop all uh, the
References.
references from the tables,
Yes.
and then it loads the data and then recreates it.
No, no, I understand that part. My question is that while this dial is processing, right, in the sense like, well, dial is dropping the references while the data is getting loaded, right?
This is the basic functionality of Guidewire. They do. We do not touch dial.
Oh, we don't have control in it. Okay.
No, no, we do not touch dial.
Okay.
I'll just show you. Just a second.
No
Give me a
problem.
minute. I'll just show you so that you can understand. I have to log in. Just a second.
Okay.
So this is the board's screenshot
Okay.
we have. So these are all data flows for
Yep.
base delta, or if it's transaction, then it's transaction, right? So base delta is a data flow which takes three parameters. One is the command line, which is common to all these,
Mm,
and three parameters. So one will be the TRF table, one is the base table, and the third is the delta table,
mm,
right? Now we just have to pull this from the, or we can copy and paste over here and define our TRF table, that this is our TRF table and this is the base table and this is the delta table. Now dial will do rest of the thing by itself.
One question there. So when we talk about the TRF table, that's a stage table.
Yeah,
Based,
right.
what is the base and the delta table difference?
So they are the main tables,
Or the target?
in which,
Okay.
yeah, target tables in which we have to push our data.
So the
Base
uh,
table is basically the SED type 1. You
okay.
know SED types?
Yes.
Okay. So base is the SED type 1 and delta is the SED type 2.
So we maintain a CD type 2 for all the tables.
Yes. For if it is base delta type, then yes. If it's a transaction, then we have transaction tables. So transaction doesn't need a SED type, right?
Transaction doesn't needs a
I'll show you.
okay. Okay.
So this is what we do in the ODS part, the dial part. That's it. Dial is very, very, very simple. We
Okay.
do not touch anything. We just
Specify the
put this
parameters.
into, yeah, parameters into the data.
Got it. Okay.
These all run in parallel.
Oh, okay. Okay. So dial is a key component in the in the info hub, right? Data
Yeah,
hub.
yeah.
Okay, understood.
Okay, then automated loading of base data. This is so the one we discussed. So automated loading of base data tables and transaction tables. Right. Now automated missing key logics. If we have some policies which are coming, we have column later arriving dimension, so that updates it. I mean,
What does it mean? What is
LAD
later?
records. LAD records are basically late arriving dimensionalities, which are records in the table that we have the policies, but we do not have their other data. So that we get the policy numbers, but we do not have other data. They are defined as LAD records.
Is it like the dimension information not available at the time the transaction comes in?
Yes, right, 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 right.
Okay.
You're right. Okay, then we come to the logical data model. So data hub contains conformed storage tables, that CS table that we saw over here, these tables, CS,
Mm-hmm.
right?
Base and delta, right? Okay.
Yeah, yeah, conformed storage tables. And we have reference tables, ref, which starts from ref underscore, and we have ETL tables which starts from ETL underscore.
What is this ref and the ETL table for?
ETL tables are for ETL purpose only. They
Mm.
hold the data for the entities, for the list of entities. Just a second, I can go to the server. I can show you an example.
Okay.
Screen. Right. So this is the ETL table,
Okay, so
which holds the data of the configuration
uh-huh.
for which it is. So it is development environment,
Okay,
and the entity
table.
is claim status, LOB code all, source system claims, uh,
When was it last expired?
start date. Oh, sorry, initial code. So it takes from here.
And this is one table for all the entity information.
Yes, for all the entity tables. We have different, a lot of, a lot of means around 20-25 tables for ETL, which helps. So we have ETL email configuration, we have ETL configs, which ETL config will hold the data of the job server name and everything. And so these are all lies into the config file,
Okay, okay,
which we set.
understood.
Yeah,
Okay,
we'll do all these changes into the configuration file.
okay,
Right. And okay, so here are some prefix names of the tables. Prefix represent the table or view type. TRF underscore represents transformation. CS underscore is confirmed storage.
storage.
Ref underscore is reference. ETL underscore is ETL support. SBC underscore is staging table for billing center. KBC is key table billing center. VTRF is transformation view.
Okay, and this is from a billing center perspective. But if it is going to be for the policy center and the claim center, instead of the SBC and the
No,
KBC, something else will come.
see, so for claim center and billing center, for policy center, we have CS table.
CS. Got it.
Yeah.
Okay. Okay, so the billing
Reference
center
will
will
hold.
not be there in the CS. It will be all part of
No,
the
no, no.
SBC and the
Yeah.
KBC.
Right,
Okay,
right.
got it. Okay.
And one important thing which is not in this slide is if we have any entity we are creating which is not available in out of the box,
Mm.
we add Z underscore before that.
Okay. So if it is not going to be, then in the case, would that be C underscore CS underscore, or would that be
CS underscore
CS underscore, right?
for policies, and same for billing center. If it's Z underscore KBC, then uh,
What about if it is going to be a non related either of the three, right? This could be also a data that is coming from some other sources as well.
then again same Z underscore has to be
C underscore.
there.
C underscore. It doesn't have to be CS. It can be anything else,
Yeah.
or it is always going to be CS.
No. See, if it is for policies, we have some tables
Hello?
that we have manuscript. So we developed some manuscript entities, uh, so which were not available
Hello?
for in that line of business. We created with the name Z
Okay.
underscore CS underscore manuscript form for that entity, for that LOB.
Okay.
We have outbound tables that are Z underscore, then we do not have CS for those tables.
Mm. Okay. Yeah, I'm sure that we'll get there at some point.
Yeah.
Okay.
So this is the base data and transaction tables. Base is the SCD type 1, delta is SCD type 2. Normally, transaction is made mutable, transactions have been updatable. So this holds the data of the transactions for all the premium paid and all those transactions that we do.
So the base and the delta is actually maintained for, so primarily the delta is actually maintained for the dimension tables.
Not
SCD.
dimension tables. We are no. Yeah, we can say SCD type 2 for delta. So there are suppose we got 10 columns
Uh-huh.
for policy,
Uh-huh.
and we have three columns which do not which will never change, which can be updated but never change, will go into the base table, and
Uh-huh.
rest of the columns which requires which will, for example, it get renewed, policy get renewed every year.
Okay.
So
Yeah,
we'll
yeah.
have the policy number, and into the base table, and we have policy number in delta table as well. Not policy number, but the policy key which will be common into base and delta, and rest of the dates which will be renewal dates will be into the delta, so for one policy number or policy key we have one record into base table, and so for from since 5 years, if I am renewing my policies, that will go into the delta tables for that policy.
Okay. Got it. Okay. And then when it's a policy here, that would be a dimension table, right?
Right.
Okay.
So we have now we have come on to the attribute names and domains. So we have uh, columns like ID, keys, and there are surrogate keys as well. We'll discuss their class. So
Mm.
attribute name should apply a class, right? So if it is ID, which is surrogate key, every table has a surrogate key except
Okay.
TRF table. TRF
Okay.
doesn't. Every conformed storage table will have a surrogate key
Okay.
of that table. So if it is base table, it will have uh, it will if it is base table, it will have BID in
Mm.
the as a suffix. Underscore BID will be the suffix for that table,
Okay.
base table, and DID for delta table, TID for transaction tables. Right. If we do not do so, so dial will give an error and we'll have a failure.
Okay. And these things, when we say that, that if you don't do it, those things are primarily when we create our own custom loads, right?
Hmm.
Standard loads will automatically come with the all these surrogate IDs in it.
Hmm.
Okay.
Yeah. So we have so all the dates should be underscore DT as a suffix. Date with timestamp will have underscore DTS. Any codified value will have CD, flag, amount, name, and percentage value. Similarly, this is the nomenclature which they follow. So nomenclature is very important in this Guidewire Data Hub.
So one question that's right, that example that I have given for the number. So for
Hmm.
example, if it's a policy number, what would be the name that you would suggest over there?
Policy underscore NO.
Policy. Oh, so it's instead of policy number, it will be policy underscore NO. So
Yeah.
transaction number will be transaction underscore NO.
Yeah, right.
Confirmed date would be confirmed underscore DT.
DT.
Understood. Okay. Makes sense.
So these are all the classes. Now we have storage tables type transaction that we discussed. These premium transaction tables. It is just a brief we already discussed. Base tables are SCD type 1, data tables.
A new surrogate keys. What does that mean? ETL row EFF underscore DTS.
These are the columns. So one row will end, so it will populate it from that day. So whenever I
Oh,
renew
okay,
my
okay.
policy,
Got it. Yeah, yeah.
next row will come into the
Oh, it's a type to date, right?
yeah.
Timestamp. Okay, got it. And so typically the end date will be always going to be 9999, the max.
Yeah, yeah.
Okay.
So and it will be 1900 1900. No, no, sorry.
It's 9999,
Yeah,
right?
9999. Right, right.
Yeah, right,
999.
right. Yeah.
And the last is the references. Reference we have. I'll just give a screenshot now. That would
Mm.
help. Okay. So we have around 1, 2, 3, 4, 5, 6, 7 tables. I cannot share my screen of the server, but we have almost around 7 tables. Could you give me a second? Just a second.
Okay.
Yes. Oh, sorry, I got a call.
Yes, sir.
So we have uh, so 3, 4, 5, 6, 7 tables around which holds the references data, which would be like our type names, which could be our EDW, and some tables are like ref conformed types, which conform table conform reference conform types, which will hold information about the EDW. It could be multiple, and so in our case it is one, and we have uh, strategies, ref strategies, which will hold the source reference source system, and we have target reference source systems, which will have along with the reference entity type code. So these are basically to hold the data of the reference columns. So for example, we have account type as reference entity type code,
Mm-hmm.
and so for that one entity type code, we will have the TRF table name and the TRF column name, which is being referenced, and the CS table name and the CS column name, which is being referenced. So all the
So the source and the
references
target is referenced here. What is the source and what is the target table?
source is the TRF tables, and
Mm.
target is the
Main
uh,
table,
main
CS table,
tables. Yeah,
CS base or this one, right? And that information is actually stored in this reference.
references tables, right?
Okay, got it.
So that's all for today.
And when will we start? So in the next session onwards, we'll start to work on the system itself.
Not on system, not practically.